Good afternoon, everybody. How are you all? I hope you are doing great. Today we'll talk about hypothesis test, specifically t-test, using Excel. So I'll share my computer screen with you. The average weight of a certain kind of egg should be certain kind of egg is 208 grams. A new batch of egg is weighed and listed below. At alpha equal to 0.05, can we conclude that the mean weight is greater than 208? So our null hypothesis, which is status quo colon mu equal to mu is the population mean, is equal to 208, is equal to 208. And the alternate hypothesis, for which we have to go through the evidence in the sample that we have collected, either to support it, or if there is not enough evidence, then we'll reject it. So HA, or the alternate hypothesis or the test hypothesis, is mu greater than 208. Okay. So as you see, the alternate hypothesis is mu greater than, the symbol indicating greater than, two slanted lines meet at an edge pointing to the right. So it's a right tail test. That means the rejection region is in the right tail. And we have not been given population standard deviation. Also, we do not know. Well, we'll assume the sample came from a normal distribution. Assume the sample came from a normal distribution. From a normal distribution. Okay, so the first thing we will calculate is the sample mean. So mean in cell A11 is equal to average, is the function we are looking for. AB, you type and average opens up, and then you highlight from A2 to A10. Okay, and the mean is 209.744. Then we will calculate sample standard deviation. This is important because the sample size is less than 30. So we have to calculate the sample standard deviation, not population standard deviation. So equal to standard ST, STDiff.S. S means sample standard deviation. Remember, the formula for sample and population standard deviations are different. In sample standard deviation, in the denominator, we divide by n minus 1, sample size minus 1. Hence, I select STDiff.S, and then I will highlight from A2 to A10 and hit enter. So that's your sample standard deviation. Now I will calculate the standard error, which is the standard deviation of the sampling distribution. And equal to S divided by SQRTN, where N is the sample size. Okay. So how will I do that? Is equal to, so in this cell, A12 equal to, standard deviation is in cell A12, then divided by is this symbol in Excel, then I will do SQ RT, square root, and the sample size, I can do the number or I can count A2 through A10. Okay, count A2 through A10. Okay, and okay, count A2 to A10. What did it do? It counted the sample size, which we know is 8. So we could have done A12 divided by square root SQRT 8. So this is the standard error or the standard deviation of the sampling distribution. Now we have to calculate the test statistic, whose formula is X bar, means the sample mean, minus mu 0 divided by standard error. Remember my mu 0, that will be X bar, sample mean, minus mu 0 is 208, because this is the hypothesized population mean. So X bar minus 208 is the hypothesized population mean divided by standard error. Okay, that's your test statistic. In this case, this will be a t test statistic. So equal to my X bar is in cell A11. Okay, and my hypothesized population mean is 208, which is in the null hypothesis, and then I divide by standard error, which is in cell A13. That is your test statistic, which is 3.12736. Now I need to calculate the area to the right of 3.12736. I have to do that because this is a right tail test. Okay, and I will compare that area with the level of significance, which is alpha is equal to 0.05. But in Excel, the function that is there, you will calculate the cumulative area. That is the area starting from the very negative value of t up until z. It's called cumulative because it calculates the area from the extreme left end of the t distribution up to 3.127. Okay, so we will get the area on the left of 3.12736. And then we know the total area under the T curve is 1. So if you have the total area on the left of 3.127 from the area under the curve, which is 1, I will subtract the area, cumulative area up to 3.127. That will give me the area to the right of 3.1276. So first I will calculate the cumulative area. Cumulative area, that is area to the left of the statistic. Okay. So how do I do that? I use equal to, then t dot dist, t dot dist. This is the function I'm going to use. T dot dist. Okay, then I have to tell them the x value. So I want to calculate the cumulative area up to 3.12736, which is in cell A14. Okay, and then I will say talk about degrees of freedom. Remember, in t distribution, degrees of freedom is sample size minus 1. My sample size is 8. 8 minus 1 is 7. Okay, and I want to calculate the cumulative area, so I'll put true. Okay, as the last argument. So what did I do? First, I put the x value. That is, I want to calculate the cumulative area up to 3.12736, which is in cell A14. So inside the parenthesis, my first argument is A14, comma, degrees of freedom is sample size minus 1, 8 minus 1 is 7, and then comma, and I have to put true to indicate that I want to calculate the cumulative area to the left of 3.12736 and hit enter. Ooh, it didn't work out. So, oh, true. My spelling was mistake. True. And that area is 0.99164. So area to the right of test statistic or p-value. How will I do that? I know the total area under the T distribution is 1 minus the cumulative area to the left of 3.127 minus cell is A15. A15. So 1 minus A15. And the p-value, so p-value is, now remember the alpha value is 0.05, level of significance. That's your level of significance or alpha value. Significance or alpha value. So what is my conclusion? P is less than alpha, because P is the area to the right of the test statistic, which is 0.008. Okay, so P is less than alpha. So P is less than alpha. So decision is reject 80. In reject 80. P is less than alpha. So what is my conclusion? My conclusion is at alpha equal to 0.05, 0.05, there is enough evidence. The rejected null hypothesis will support the alternate hypothesis. There is enough evidence to support HA, which is mu greater than 208, which is mu greater than 208. So we rejected H0 because at alpha equal to 0.05, because we rejected the null hypothesis, because the p-value, which is the area to the right of the test statistic, 3.127 is 0.008, which is less than alpha of 0.05. Therefore, we rejected the null hypothesis. And we concluded that at alpha equal to 0.05, there is enough evidence to support HA mu greater than 208. So to summarize, what did we do? First, we calculated the sample mean, sample standard deviation. From that, we calculated standard error, which is sample standard deviation divided by square root of the sample size. This is the standard deviation of the sampling distribution. Then we calculated the test statistic, which is sample mean minus the hypothesized population mean of 208 divided by standard error. This is 3.127. Then using Excel, we calculated the cumulative area, that is the area to the left of the test statistic, 3.127. This area is pretty large, 0.9916. Then to calculate the p-value, because this is a right tail test, p-value is the area to the right of the test statistic, which is 1 minus 0.9916, which is 0.0083. Now compare this p-value with the alpha value of 0.05. So p-value is the area to the right of the test statistic. P-value is less than alpha value of 0.05. Therefore, the decision is reject H0. And conclusion is at alpha equal to 0.05, there is enough evidence to support the alternate, which is mu greater than 208. So I will stop here today. If you have any question or comment, write me a note. I'll respond to you right away. If you like this video, please give me a thumbs up. I appreciate that. If you like this video, please share with all your friends. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. I have all kinds of solution in my problem solutions in my channel. You can take a look, statistics, algebra, all kinds of math. Okay. So see you next time. Take care. Have a nice day. My goal is to help you solve math problems. Okay. See you next time. Take care.